Hello. In this video, I'll be going through the probability content for the OCR GCSE Foundation Maths exam. To start off with probability, we're going to be looking at a probability scale. This is typically going to be a number line which ranges from 0 to 1, or it could even be 0 to 100%, and you would have to be able to put events on this probability scale in order from impossible at 0 up to certain at 1, with 0.5 in the middle being evens. Certain questions will actually have arrows on the diagram and you will have to match it to a given set of events, such as a spinner. And sometimes you might be given a spinner and you'll have to draw arrows on the diagram to match it. So just ensure that you do read carefully and think about how the number line has actually been split up, because sometimes if it was, say, for a dice, they'll split it into 6 equal sections, and so you want to make sure you look at the dice carefully and think about how many sections along the line you want to be. Relative frequency is the probability of something happening using experimental results. So in the fraction format, you would have your numerator being how many times the event happens that you want, and the denominator would be the total number of times an experiment has taken place. Now this might be in the form of a table that is presented and you'll have to come up with a probability, or they have started using what are called frequency trees, which look like probability trees, but instead of having fractions along them, you will put the actual frequencies and how they split. You do also want to understand how to use relative frequency as an estimate of probability. So we don't know the exact probability for this experiment, but the relative frequency is our estimate and it is going to be close to what that probability should be. We do need to understand that if you do more trials, so if you was to repeat the experiment more and more and more, that the relative frequency, the probability you get from the experiment, will gradually get towards what the theoretical probability would be. So if you're rolling a dice and it starts to land on a number, say 2 out of 10 times, and so that's a fifth, if you kept doing that experiment more than 10 times, gradually you should get your probability towards 1/6. When doing questions on probability, you do want to make sure you use fractions, decimals, or percentages as your answer. In most questions, it's going to be fractions or decimals, as these are the most common ways of representing probability. You'll also want to make sure that you are aware of equally likely outcomes and how that plays a role in getting your probability. So on the right is a question about letters for the word November being put on cards, and one of those is going to get chosen at random. Now each card has got the same chance of being picked. So when we're looking at the probability that she takes a card with an E, the numerator will be the number of E's that there are, and the denominator will be how many cards there were to choose from altogether. Now in this case, it would certainly be easier to use a fraction to start with rather than going straight in for a decimal, and that's what most basic kind of questions on probability are going to want you to do. You want to understand the idea of randomness and fairness in simple experiments. So randomness means that each number or letter or whatever it is has got the same chance of coming up, or it is completely random what happens. You can't necessarily predict the next step. So if you flip a coin and it lands heads and then you start to flip a coin again, that doesn't mean it's going to land tails just because it landed heads before. That doesn't change what the coin is going to do. The coin doesn't have a memory. You also want to understand fairness from the point of view of bias. So if an experiment takes place, do the results show that it was fair? So if you're rolling a dice and say 3 comes up more than any other number, then that dice might not be fair, and so we might refer to it as being called biased. You want to be able to calculate probabilities for simple combined events. So if you was to roll 2 dice and look at the totals, what you can draw is a sample space diagram and be able to keep a record of all of those combinations. Now typically that diagram may be pre-drawn for you. Some questions recently, rather than just saying you've got to add the 2 numbers, they'll actually come up with slightly different rules to make it a little bit more difficult for what's going to be in the table. A follow-up question is then to come up with a probability from that table, so making sure you use all those combinations correctly and you think about the wording. So if it says the probability is greater, the total is greater than 10, then that's not going to include 10, it's got to be greater than, so do check the wording. Once you are at a point where you've got probabilities already being given, and so this last question about Megan and rolling a dice 400 times, you want to be able to use those to estimate how many times an event may happen. So the standard way to do this is to multiply the number of trials that you do by the probability. Now this could appear in calculator or non-calculator, so you want to make sure you do know how to multiply either a whole number by a fraction or by a decimal in order to do that. As I mentioned previously, when we are combining events together, we will want to make sure we're using a sample space diagram to keep a record of what we're doing. So the grid below shows what happens if you looked at a 10-sided dice and a coin. What combinations could you get? Well, the dice could land from any number from 1 to 10, and the coin could be heads or tails, and so this creates a total of 20 combinations. Sometimes you might have to calculate the total number of combinations by multiplying how many of each outcome there is together in order to get that total. The questions that follow can get a little bit more complex, so you just want to make sure you're careful about how you use the table accurately. The next thing to look at is how you actually go about systematically listing all combinations from an event, and this has the fancy title of enumeration. And so what you want to do is develop a strategy. You want to make sure that you do get every combination. You want to use abbreviations for words rather than writing them out in full, because that will waste time in your exam. Some questions will list this, give you a table, to put your information in, and so you want to make sure you use that. Venn diagrams will be something you've seen, and you want to be able to get probability out of Venn diagram situations as well. Sometimes the Venn diagram will have the total numbers inside them rather than the list that I've got here, but then you want to be able to actually look at the probability that you choose a number from set A and so on. So you want to read carefully what the information is and then do that. Now, I've not seen many questions in the exams about using the set notation, but it is important that you understand what it means. So in the example I've got on the right, set A, and that circle there represents all the even numbers, and set B represents the prime numbers. So 2 is in the intersection where it is both even and prime, so it's in that overlap, and 9 is not even and it is not prime. So in which case it sits outside the circles, but it's still inside the rectangle. The rectangle represents all the numbers, which in this case were the numbers from 2 through to 9. So like I say, the set notation that you see on the right there, where it's using sort of some fancy notation with curly brackets, that's not as common in exams. So I'm not going to go through that in too much detail, but you just need to be aware that sets can come up like that. The next thing, which is more common to come up, is a question about tree diagrams. These often involve partially completed tree diagrams. So it talks about tree frames. And so in which case you normally get a couple of marks for completing the diagram, and then you'll get some follow-up marks for some extra questions. Tree diagrams will typically look like this one with 2 outcomes at each point. And as you flow from left to right, you're looking at how the probability will work if, for example, in this case, you had 2 reds, a red and a blue, and so on. And then your follow-up question would be, what's the probability that you get 2 reds? What's the probability that you get 2 of the same color, and so on? So there are some laws of probability which it goes on to, and you do need to understand some basic ones. Now, the first one that most people are aware of is that probabilities for mutually exclusive events will add up to make 1. So in this case, there were counters, they were either red or blue, there were no others, and if you look at the fractions 3/5 and 2/5, they add up to make 1. Tree diagrams don't always use fractions, they can use decimals, and I think I've seen the odd one with a percentage, but that's quite rare. And so you want to make sure that within your strands, your trees, branches that are going across, that those ones are adding up to 1 in their little pairs here. The second one, which is not one which I've seen very often, is about the OR rule for probability. Now, it doesn't normally have that part at the end where you've got to subtract the probability of A and B. Now, that would be true in the Venn diagram where you've got that overlap, and that's possible. But in this case, it wouldn't be possible. So if I said, what's the probability that you get 2 reds or 2 blues, that would be a straightforward addition. You would add the probability of getting 2 reds to the probability of getting 2 blues. So you don't overly need to worry about the subtraction bit at the end, because I've not seen it. That would only be in the case of a Venn diagram problem. What can be more common, and I didn't go through last time because it was mentioned in this next slide, is about the multiplication law of probability and conditional probability. So in this example here, there were red and green beads in a bag. And so initially there were 9 beads. And so one of the beads was taken out and it was not put back in. So what happens when you get to the next branches on the probability tree is you've got 1 less bead. And so your probabilities are now out of 8. Now, depending as to whether it was a red or a green bead that came out, that would then affect how the numerators will look on the next part. So along the top, because a red bead was taken out, the number of reds in the second section went from 4 to 3, and so you have to take that into account. I've not seen too many conditional probability questions, but this idea of multiplication law you will use. Now, if I wanted in this case to get the probability that I chose a red followed by another red, as I go along the diagram from left to right, I would need to multiply. So I need to multiply the fraction 4/9 by 3/8, giving me an overall fraction of 12/72. Now you could simplify it, but one of the things with probability is you may not have to simplify. So sometimes it's best not to, and in these tree diagrams, I wouldn't recommend it. Then at the end, you may have to add some probabilities. So as you go left to right, multiply your fractions, and then you should get 4 fractions at the end. And if you want to start adding combinations of those, that would be when the OR rule kicks in. So if it wants to know about that you get 2 counters which are different colors, then that's going to be red green or green red, and you'll add those probabilities together. Now that's the end of the video about probability. With probability, like I mentioned earlier, avoid using ratio. It's not likely to work out and get you marks. They don't appear in the mark scheme as ratios. You want to make sure you use fractions as appropriate. Try and avoid using words as well unless you're really told to. So if a question says, you know, what's the probability of something happening, don't write something like likely. You want to be sure that you can write it as a fraction, a decimal, or a percentage in order to give yourself the best chance of marks. Now that's the end of the probability video, so hopefully that's helpful or giving you an idea of some places you might want to look at to revise.